Hey guys, let's talk about exponential functions for a second. An exponential function generically is just written as f of x is equal to a times b to the x. And what makes it an exponential function is the fact that our variable is a part, an exponent, it's an exponential function. A and b are constants. So this is assuming that a is not equal to 0. B needs to be greater than 0. And the reason for that is if b is negative, we don't have a constant function anymore, because you have to be concerned if x is an even number, all of a sudden a negative number becomes positive, and so you're going to have a graph that's jumping all over the place. It's not constant anymore. The growth isn't consistent. For an exponential function, you're going to have either exponential growth or you're going to have exponential decay, and I'll show you the difference of that in just a second. You also have to assume that b is not equal to 1, and I'll show you that as well. So let's just take a very simple graph of y equals 2 to the x. So in this case, our a is just 1, our b is 2 to the x power. And if we were just to graph this, let's start with x equals 0. 2 to the 0 power is just equal to 1. In fact, a lot of times the generic exponential functions are going to cross the y-axis at 1. And the only thing that the a will do is it will shift that up and down. If a were 3, then it's going to cross at y equals 3. Let's just continue with this. If x is equal to 1, then y is 2. If x is equal to 3, then y is 8. And this is where you start seeing that exponential growth. It starts going up very, very quickly. Now, what's happening on this side of the y-axis? Let's say x is negative. Let's say x is negative 1. Well, 2 to the negative 1 power is the same thing as saying 1 over 2 to the first power. So negative 1 takes us here at a half. Anytime we have a negative exponent, it's just going to flip it over into the denominator. And so rather than going up very quickly, it's going to start going down, but it's going to start decreasing slower and slower and slower until it's never going to reach the x-axis. The x-axis will become an asymptote, but it'll get closer and closer to that x-axis, okay? So if b were equal to 1, so if we had y equals 1 to the x, well, it doesn't matter what x is at that point. It's just going to cross, well, you're just going to get a straight line somewhere, depending on what your a is. But there's no exponential growth, there's no exponential decay. So we're just taking a look at how fast this is going up or how slowly it's decreasing. So consider then what would make the graph go the other direction. Okay, that's the exponential decay. The blue line represents exponential growth. The red line represents exponential decay. So what in this function then is going to turn this into an exponential decay? Well, anytime you have your b value, if your b value is between 0 and 1, now it can't be either 0 or 1, but if b becomes a fraction, it flips it over on this y-axis and we get this exponential decay for the same reason that we have this example here. Because now we start off with fractions to an exponent, and so now if we change that exponent to a negative, then they become whole numbers and we get exponential decay. So hopefully that helps you get an idea of what's happening with exponential functions. We'll do some here in a little bit. We'll do some practices with this and what this might look like. We'll have a generic graphing form of this particular function, so it's very easy to see, okay, where is it crossing my y-axis? Is it shifted up or down? Is it shifted left or right? All of that happens in very generic form and makes it very easy to graph even without a graphing calculator. So hopefully this is helpful to you. If so, please like and subscribe, pass this information on to others that it might be helpful to. And as always, thanks for watching.